So now I'll be solving question number 5 from previous year problems, chapter called Laws of Motion, phase 1. This is the question which came into 2000 in IIT exam. So this is a little nice question, good question. So a long horizontal rod has a bead. The bead will be surrounding the rod actually, which can slide along its length. So bead can, if possible, bead can slide along the rod. Now it's initially placed at a distance L. So initial distance of the bead from the axis is L from one end of the rod. The rod is set in angular motion about A. So we have a rod. Actually, this is a rod. And this rod is rotating with a constant angular acceleration alpha. So don't get confused. This is constant angular acceleration, not the velocity. The angular acceleration is alpha and this is constant. And bead is somewhere here. Initial distance is. Now, if the coefficient of friction between the rod and the bead is mu, so between this, the friction is given as that's the maximum value. So the gravity is neglected, so we have to neglect the gravity. Then the time after which the bead starts slipping. The bead will start slipping after some time t, and we have to calculate that time. So obviously there will be a force, driving force, which tries to move this bead away from the axis. And there will be a resistive force, which will try to prevent the motion in the backward direction. So driving force in this case will be the centrifugal force, and the force which is trying to prevent the motion will be the friction. So when the centrifugal force will be more than or equals to friction, the bead will just start moving. So we have to calculate the friction as well as centrifugal force in this case to check where it will move. Now to calculate friction, we need to calculate the N. So in this case, for critical condition, we are talking about critical condition. Critical condition is when it will move. So condition for like critical condition, what we do, we make the friction as kinetic and acceleration at that point of time, we keep it 0. It's just about to start. The friction will be kinetic and the acceleration will be 0. That's the critical condition, always. And we know that kinetic friction depends upon the normal reaction. So kinetic friction value will be equals to mu times of N. So to calculate kinetic friction, I first need to calculate the normal. Generally, the normal is to come from the mg, but g is not there. So somewhere else, this is coming. The somewhere else is the tangential acceleration ultimately. So you see, alpha is given, and we know AT is R alpha. The tangential acceleration is equals to R times of alpha. So when I talk about the bead, if the rod is moving, the bead is also performing the circular motion. If the rod is accelerating, the bead is also accelerating. If the bead is accelerating, then what is providing the acceleration to the bead? If I make the SPD, there will be a normal reaction. And that normal reaction will be providing the tangential acceleration to this bead. It's like this. The bead is connected and the rod is moving, the bead is also moving. The normal reaction from the rod onto the bead is moving the bead. So when I calculate the normal reaction, that will be equals to m into AT. The mass of the bead multiplied with AT, so m R alpha. The normal reaction comes out to be R alpha. From this normal reaction, we'll be able to calculate the maximum value of friction, which is Fk, and that will be equals to mu times of m. That becomes mu times of R alpha. This is the friction. So we have got the friction in terms of alpha. Now, let's focus on the centrifugal force. So centrifugal force, the formula is mr omega square, or you can say mv square by r. So to calculate the centrifugal force, I need omega. So omega for the rod and omega for the bead is same, and rod is accelerating with alpha. So let's calculate the omega for the rod. Omega for the rod and omega for the bead is same. So let's calculate that. We'll use the kinematical equation for it. First kinematical equation for circular motion. So that is omega is equals to omega naught plus alpha t. That's the equation. First kinematical equation for circular motion. So alpha is the angular acceleration, which is constant. So after time t, the angular velocity will be omega. So how much omega we are getting as a function of t? That is alpha times of t. So after time t, the omega coming out to be alpha times of t. So centrifugal force after time t will be r. Now radius. So when this bead is performing the circular motion about this axis, the radius of the bead, circular motion of the bead will be L. So in place of r, we will be writing the L. So ml omega square, which is alpha d whole square. So the friction force, maximum friction force acting upon the rod or bead, and the centrifugal force as a function of time onto the bead we have calculated. Now for sliding, the centrifugal force should be more than or equals to SK. The thing is, we are talking about critical conditions, so we'll make it equal. Because we are talking about when the motion will start. The motion will start when the FC will be equals to. So it will be ml alpha square t square will be equals to mu times of r alpha. So alpha say one time alpha gets cancelled, mass gets cancelled. And this radius is nothing but L only. So that gets cancelled. So t square is coming out to be mu r by alpha. Sorry, this gets cancelled here. So this is coming out to be mu by alpha. So that gives t as under root of mu by alpha. So time is under root of mu by alpha. If I check the options, the option A is the under root of mu by alpha. So option A is right. Now in this question, what we have seen basically, the bead condition, we know like in this case, mg is not there. So if mg is not there, some force will be providing the normal reaction ultimately. And that came from the tangential acceleration. If mg would have been there, then the normal reaction would be the net of this square plus mg square under root of that we have, because this force is along the tangent. So that would have been a little trick. So in these kind of questions, always keep in mind, this is the critical point. How we are getting the normal reaction. This is the critical point. Whenever these kind of questions are coming, we should focus on how we are going to get the normal reaction. Because once we get the normal reaction, we will be able to get the kinetic friction. And then it's just about the centrifugal force more than the kinetic friction, which is the maximum available friction body will move. Okay. So I hope you understand this question. It's a very nice question. It should be like some permutation combination of this question, different variation of this question also to get the better understanding of these type of problems. Okay. I hope you understand. Thank you.